I've got a lot to talk about in a fairly short period of time, and as I was thinking about putting these thoughts together and some slides and things like this, I really had a hard time selecting what to put in it to try to cover this sort of this sea, this ocean of information, in a sense, that to me is so convincing. It is really so convincing, and my convincing or my sort of enthusiasm for this work has really come about because of the evidence in the research world that I've been involved with for now, gosh, 40 to almost 50 years, I guess, 40-some years. So I'm just going to sort of touch the tops of some waves and tell you why I think this is so important. It unfolds, though. My comments really unfold, in a sense, with my own sort of research career, if you will. I hope you forgive me for that. But I did, in fact, with my colleagues, my many, many students, fellow professors in some cases, not all, obviously, did, in fact, go through this and sort of asking the obvious questions and then going to the next questions and so forth and so on to finally come to this point where I guess I have to say I'm a vegetarian or a vegan. And that's not where I started out to be, as Doug has pointed out. But the evidence is really so powerful, and I'm sure that many of you appreciate that, and the distinguished group of speakers that you will be hearing here, I think you'll enjoy. They have been pioneers in this field. And so I'm just going to kind of fill in some cracks insofar as the research is concerned. Okay, let's start with the problem. You know the problem. I just decided to put down a few thoughts here that, just to tell you, the problem is really big. Adults overweight, 65%, a third of us are obese, the youth are especially vulnerable. During any given week, according to some surveys, half of us take at least one prescription drug in this country, and 4 out of 5 of us take some kind of medication. But yet, the drug reactions, the adverse drug reactions and other medication errors make it the number 3 cause of death in this country. 225,000 people a year. How many times have you seen that? Heart disease, number 1, cancer, number 2, and going to the doctor, number 3? That's a pretty tough message. Yet at the same time, the cost of medical care in this country is the highest it is in the world. Germany's second, it's only 60% of us. So we're paying a lot in many ways. And so in the final analysis, we now know that most of these disease-related deaths, really quite frankly, are preventable by diet. So if we can solve this problem or help to solve this problem through dietary approaches, there's 2 ways, the way I think about it, as I look back. There's 2 ways. One I call the pharmaceutical approach, where we use single nutrients, like nutrient supplements and things like that, or their analogs, where the long-term benefits are highly questionable. And incidentally, just this, maybe 2 months ago, there's a really substantial report now coming out summarizing these multiple mega-million-dollar studies that have been done on nutrient supplements, concluding in fact that vitamins A and C and E don't work. Really, they don't work, not in the long-term benefit. But in any case, that's the pharmaceutical approach, taking a single chemical coming out and claiming that's nutrition. Nutritional approach really involves the highly integrated effects of all the so-called nutrients or chemicals in food, as food. It's a natural sort of way. Now, let's look at a little bit of the background, because as I said, I go back some 4 or 5 decades, and I can tell you that as I look back, this particular chart here was key. It was a chart that was put together by Ken Carroll, the late K.K. Carroll at the University of Western Ontario, where he basically compared the breast cancer rates for different countries. Some others did this too, but Ken's work was particularly notable in this case. And what he showed is that there are big differences between breast cancer rates in different countries, number 1. And number 2, it seemed to show this really impressive relationship with dietary fat. And it was from this particular body of data that really gave rise to some policy and some education and some other statements about 20, 30 years ago that we should cut down on our fat intake. That plus the information on fat and heart disease as well. But in any case, this kind of plot here, one could put breast cancer on that y-axis, colon cancer, heart disease, and so forth and so on, and see that kind of relationship with dietary fat. That's why we got caught up in this idea of thinking about dietary fat. Okay, the second point to make about that previous slide is that there now have been dozens of studies, so-called migrant studies, when we know that when people move from one risk area, from a high risk area to a low risk area, vice versa, they get the disease of the country to which they move without changing their genes. Interesting. So it's an environmental, and would argue largely a dietary sort of phenomenon. But I sort of wonder a little bit why it is that these days we're emphasizing genetics so much as a cause of disease. I mean, I'll just say this, every single biological event that we experience starts out with a gene. But that does not mean the genes are sitting there and sort of doing their own thing. These genes have to get expressed, and that's where nutrition comes into play. And so, quite frankly, we've known in the field for a long time that not more than 2 to 3% of cancers, for example, that is really attributable to genes. It's nutrition. Okay. Largely from these migrant studies. My own work, formally at least, after I got out of graduate school, was getting involved in a big nationwide program of feeding malnourished and starving children in the Philippines with my senior mentor at the time, Butch Engel. It goes back to the 60s. Got things backwards here again anyhow, sorry. When we went to the Philippines, and because of my previous training, trying to grow cows better and regarding the animal protein so highly, we were led to believe that if you're going to actually feed kids in the third world, one of the most important things is to make sure they got enough protein. And what they generally meant by that was making sure they got enough animal-based protein. Okay? So that's what I did when I first got involved in the Philippine study. But then I noted through sort of happenstance and, as it were, an observation, namely that higher protein intakes, quite frankly, were associated with higher rates of liver cancer in children. We had another project going trying to figure out what really caused liver cancer, by the way, and we thought it was related to a so-called mycotoxin or a mold toxin called aflatoxin, and that was the theory of the day. And in any case, what really turned out to be the case, and this was exactly the opposite what, in fact, I had been taught, the people who were getting liver cancer were the ones consuming, like us, the highest intake of animal protein, or animal-based diets, if you will. I didn't think too much in terms of protein per se, but eating like Westerners. It raised the question, the great American diet causing cancer? Really strange and pretty provocative. I told that to some of my senior colleagues at the time. They thought it was a bit nuts, and I shouldn't go there. But about that same time in the 1960s, there was some work came out of India with experimental animals where basically animals fed either normal levels of protein, 20%, that's the normal level, or the lower level, 5%. And keep in mind, most of my remarks are going to concern this range of 5% to 20%. So animals fed 20% as opposed to animals given 5%. The ones given 20%, the normal level, they all, 100% got the liver tumors. They previously, both sets of animals had been exposed to the carcinogen, but they all got the tumors. The animals that got the much lower level did not. Really quite strange, but very significant. This then led to a long series of studies that was funded by the National Institutes of Health, by NIH, published in a number of different journals, also funded to some extent by the American Cancer Society and other places. I point this out because at this time, this work really was handsomely funded, quite frankly, by funding from our public till and from professional agencies, and did, of course, get published extensively. And you might wonder, how did that happen if I'm coming on this idea of protein? Well, in those days when we were doing this, I was focused on trying to understand what caused cancer. And so we were looking at this sort of model, if you will, studying all these mechanisms of cancer. So the question that we had was, did liver tumors really grow faster when rats are fed normal compared to low-protein diets? That was the question, because here the Indian workers have found this. And secondly, what we like to do in research, we like to say, oh, let's look and find the mechanism, as if there is the mechanism. And so, I mean, that's the way research today is done, in fact. We have to go in there and probe all these little details. So there's two main questions. And now I just want to summarize for you just 2 slides summarizing these extensive numbers of studies just to illustrate a point. what we basically found was that we could turn on and turn off tumor growth simply by changing the level of protein intake within that 5 to 20% range. I mean, it's really quite remarkable, and I could show you many different ways of looking at that question that we pursued and got that result. It was very exciting in a sense, in some ways. To see something just like protein within that normal range that we actually consume ourselves, just turn on and turn off tumor growth. I could get into some of the details there on that particular slide, but I won't. I think you can see what I'm talking about. Over time, incidentally, in this case, it's early tumor formation, early cancer. Okay, so we worked with early cancers for some reasons, and without actually going to full-blown cancers. Finally, the ultimate study was done, at least in this particular case, where these are animals, for example, that were fed for their lifetime protein intake at different levels, 5%, 12%, 20%. Look in the top panel there. And if you look across to the right where it says tumor severity, you can see the animals fed the normal levels at 20%. They had a tumor index, if you will. That means numbers of tumors and the size of tumors and all that. 3,300 and some. The animals fed 5%. It's 248. In other words, huge difference. So we were answering the first question. This normal level of protein just turned on tumor growth. It's amazing. 12%, which is just above the level they actually need for growth. Even there, it was turning it on. But once you get below 10%, we looked at that, you didn't see really much any activity. Protein is required, by the way. It's obviously an essential nutrient. But what we were basically showing was when we went above the level that actually was needed, that's when the problem started. And quite frankly, most of us consume more protein than we need. Okay, here's the real kicker. The 5% animals, which my colleagues all thought would have been dead, with tumors at the end of their life, weren't. They were all lifty, jumping around the cage, living. They were all thrifty, sleek coats, very much alive, and essentially no tumors. The animals fed this good level of protein were all dead. So here we were seeing, really, in the most robust, extensive kind of study that we could think of doing, showing that just normal levels of protein had this dramatic effect on causing this kind of tumor growth. And there's, quite frankly, there's no other nutrient that can have this kind of effect at this particular level. Then in the bottom panel are some other additional sort of observations where we did things like to see if we could intervene. In other words, as tumors are growing up to a certain point in their life, and let's say a quarter of the animals are already having tumors that with 20% and then switching to 5%, they get to 2013 at the end there compared to the 33. In other words, without getting into too much of the details, what we were basically showing here was that even when tumors are already present, we're not now talking about preventing too much. We're talking about tumors already growing robustly. They're there. And we change the nutrient intake, the protein intake level, and we could switch off fairly late in the process. It's a really kind of interesting idea. So finally, I'm going to tell you what the protein is. I didn't talk a lot about it, certainly not in the grant applications that I was getting and so forth, but this protein was casein, cow's milk protein. 87% of cow's milk protein. And I've had quite a lot of experience with the agencies, both in this country and abroad, with the United Nations, who look after deciding, what's a carcinogen and what's not. And there are certain criteria that these folks follow. Criteria that determine when we decide a chemical is carcinogenic, if you will. The IARC, the International Agency for Research on Cancer. If I apply that evidence, these criteria that's used by everybody else to decide what's a carcinogen, I have to conclude there's no other way. And I've given this seminar to professional audiences in universities about 4 or 5 times now with this chart. And I don't get any questions, I don't get any comments. Everybody sort of sits there and kind of stunned. But quite frankly, I have to say that casein, which I'm going to argue is reflective of a larger sort of body of evidence having to do with animal proteins in general, is a carcinogen. It's the most significant carcinogen we consume. Forget about DDT and dioxin and things like that. We're talking about animal protein.